Myself S.P.Priyadharshini, Assistant Professor from the Department of Computer Science and Engineering, Bharat Institute of Higher Education and Research. So today I'm going to explain about the topic number systems from the subject digital electronics. So let us move on to the topic. So these are all the agendas that we're going to discuss in today's presentation. In this presentation, the main thing, the first we're going to discuss about the number system. What is a number system? What are all the characteristics of number system? And what are all the classifications of number system? Then next comes the types of number system. So in that we are having 4 different types of number system, that is decimal, binary, octal and hexadecimal. And at last we're going to see about conversions among these different types of number systems. So let us move on to the topic. So number system. So what is a number system? So before that, today's digital devices like your mobile, laptop system, whatever, every devices will process the numbers, only the numbers, that is the binary numbers, which is zeros and ones. Okay, so the number system is a method, it is a kind of format which is used for denoting the numerical values. Why? Because the system can process only the numbers, not any kind of a language like English, whatever, anything. So while coding a program, you will be giving the input, the programmer will be giving the input in a format of code of their desired language like C, Java, whatever else. So while coding, they will be coding the program using the syntax of such desired language. So inside the processor, after fetching the input inside the processor of the any digital device, what happens means those code will be converted into the numerical values. Okay, so after getting converted as a numerical value, then only the processor can process those numbers. So before converting each and every element, each and every input data given as a code in any kind of language, the number system used to represent the conversion. Okay, so in the number system we will be having the two major types of number system, that is non-positional number system and positional number system. So we know that the major difference is the term position. Okay, so we know that position means that is the index position, that is where the number has been present. So how to determine that number, how to define that number, what are all the characteristics of number, that will be determined by this classifications. Okay, so the first one is non-positional number system. Non-positional number system is nothing but those numbers will not be defined by any of the position. Okay, it will be used in the real time for any kind of numberings. So like a queue system, or for example we'll be using the Roman letters for each and every number, for representing 1, 2, 3, likewise we'll be using the Roman letters. So for arranging or queuing, we'll be using those numbers, that is called non-positional number system. It will not have any different characteristics, it will be arranged in a sequential order, that's it. And next is the positional number system. Those positional number system will each and every element of that positional number system will have a different characteristics. Okay, so in this presentation we know that we'll be having 4 different types of. So the decimal, binary, octal and hexadecimal are the 4 different types of number system. All these 4 different types of number system will comes under the positional number system, this classification. Okay. And next is the characteristics of number system. What are all the characteristics of number system? The first one is the symbol. Each and every symbol present in the number system pattern, in the pattern of string, each and every individual symbol is called as digit. Okay, and next is the each and every symbols will be represented using different values. Okay, that depends on the position, what kind of position it is depending, where it is present. Likewise, based on those characteristics, the symbols, the digits will be represented. Then before moving to the different types of number system, let us know what is a bit. Okay, so because bit means each and every individual element present in the any kind of number system. Okay, So the processor will process input in the format of bits. Okay, it will take each and every single bit as an input for its process, and after that, each and every bit will get processed. Then the output will be shown to the user together. Okay. So the bit, the abbreviation for the bit is binary digit. Okay. So what is a binary? Bi means two. The binary elements that is present in the digital electronics, that is 0 and 1, two elements. Okay. These two elements rules the microprocessor processing. Okay, the whatever the value you are giving to the system, the processor inside your central processing unit will process those elements as zeros and ones. Zeros and ones are the machine understandable language. The next is the bit in the bit in the computer terminology means either 0 or 1. Okay. So two elements. Okay. And next is the binary number, which consists of n bits, is also known as n bit number. So n here stands for the pattern, the size of the numbers. So next is the we're going to see about positional number systems. As I said before, all the four different types of number system will comes under the classification called positional number system. So what is the these are all the how to determine the positional number system. The main, we need three more main elements in order to determine any kind of positional number system. First one is the digit. Digit is each and every individual element, and next is the position, where it is presented and through which number, which value it has been represented, and next is the base. Okay, base point is also known as radix point. This point determines the what kind of which number system the number will comes under likewise. So see here, so the base is the total number of digits in the number system, and the main rule which the main rule of characteristics in the positional number system is the maximum value of a single digit is always equal to 1 less than the value of base. Okay. So next is the first type of a number system, that is decimal number system. So the radix point is nothing but its base. Okay, if I am giving any number like 145, that is 145 with the base of 10 means it comes under decimal number system. So here the position, it is a type of positional number system. So in the two major classifications of number system, decimal comes under positional number system. So it will be each and every digit in this decimal number system will hold the some position. Okay. So here we have, it has 10 symbols or digits, whatever, each and every element is said to be digit or symbol. So here the decimal number system consists of 10 inputs. Okay, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is having, in total it is having 10 values, 10 symbols as input. The base value for the decimal number system is 10. Okay, then next is the maximum value of a decimal number system is 9. Okay, it will have only the single digits, single value digits. Then next is the power of the power, we can set it as, we can also set as the base or radix point for the decimal number is 10. So what are all the numbers which is given as a input with the base 10 means it comes under decimal number system. This is the number which we use in our day-to-day life. We'll be using the for mathematical calculations, for anything we'll be using the numbers. No, those numbers comes under decimal numbers. So here is the example for the decimal number system. So see here 2586 with the base 10. So if any number which holds the base as 10 means it comes under decimal number system. So how to calculate this decimal number means, so see here, each and every digit is nothing but each and every individual number that should be multiplied with the base value to the power. Power means, see here, its position. Here the position of the value, any value which starts from the right hand side to the left hand side. So the position of this value is 0, 1, 2 and 3. Okay. So see here, how to calculate this is 2 into 10 to the power 3, because 10 is the base point of the decimal number system, and to the power 3 because of its position is 3, and plus 5 into 10 to the power 2. Since 5 presents at the position of 2 with the base of 10, so and then place 8 into 10 to the power 1 because its position is 1 and its base is 10, and plus 6 into 10 to the power 0 because its position is 0. Okay, so while giving the position to each and every symbols in a pattern, we have to start from the 0, that too from the right hand side to the left hand side. Then after calculating, if we add these numbers together, we'll get the value 2586. Okay. So next is the binary number system. So before itself I have explained that binary. Bi means two elements, two inputs. So the two inputs are zeros and ones. And also the main thing is the binary number system is also comes under the positional number system, and it has the two symbols, that is zeros and ones. So it is having only the two set of inputs. So its base point is 2. Okay, so see here the maximum value, this point we know that already, that is maximum value of a single digit is 1, that is in this set of input the maximum value is 1 and the minimum value is 0. Okay, and next is the while calculating, while processing this binary number system calculation, we have to multiply each number with the base 2 to the power of the value, okay, power of the digit. Okay, and these numbers used only in computers. In our day-to-day real life, we won't be using the binary numbers for our calculation. It is used only by the systems. And here is the example for the binary number system. See here the given input is 1 0 1 0 1 with the base of 2. Okay, so here the base 2 determines that it is the given number is the binary number system. In case if you are having the base as 10 means it will comes under decimal number system, then the calculation will be done as each and every symbol into 10 to the power. Okay, so see here let us arrange the positional values, that is for this one the position is 0, 1, 2, 3 and 4. Okay, so see here 1 into 2 to the power 4 because the base value is 2 and its position is 4. So 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So if we, after calculating, if we add the values, it will become as 21. Okay. Here 21 is nothing but a decimal value, so we are representing it is representing the value using the decimal base, that is 10. Okay, because the binary numbers, binary pattern numbers will have the values as only zeros and ones. The next number system is the octal number system. So in general, octal means 8. Octal represents the value 8. So it has the 8 symbols. In total, it is having 8 symbols. Before that, the octal number system is it is also a kind of positional number system. Okay, so what the positional number system means? Each and every symbols or digits in the octal numbers input will have some particular positions. Okay, it will be determined by using the particular positions, and here we are having 8 symbols, that is 0 1 2 3 4 5 6 7. So 0 to 7, in total 8. So here we are having 8 inputs, so the base value for octal number system is 8, and here the maximum value is 7 and the minimum value is 0. And also while calculating, we will be using we have to multiply each and every numbers given pattern into 8, that is base with the base power to the power of position. Okay, let us see the example. See here, and while conversion, no, this point we have to remember while conversion, that is each and here we are having for octal numbers, we are having the 8 digits as the input, no. So we know that 2 to the power 3 is 8. Okay, so while converting any kind of numbers into octal numbers, we have to make it as a group of 3 numbers. Later on we will see that example in the conversion topic. Before that, let us see the example for octal number system. See here, the given input is 2057 with the base of 8. Base 8 represent that it is a octal number system. Okay, so So what we have to do means we have to multiply each and every number with its base value along with it with the power of its position. So we know that we have to give the position for each and every symbols in the given input. That means it starts from the right hand side to the left hand side, that also from 0, 1, 2 and 3. Okay. So see here, 2 into 8 to the power 3, 0 into 8 to the power 2, 5 into 8 to the power 1 plus 7 into 8 to the power 0. After processing, if we get, this is the value, that is 1071 with the power of, with the base of, sorry, with the base of 10. Okay. So here the base 10 represent that the answer, the output number is the decimal numbers. Decimal numbers are day to day life, we are using the numbers that we are using in our day to day life. So what are all the numbers that is given in any kind of number system, that should be converted into decimal number system. Then next is the last number system, is the hexadecimal number system. It is also a type of positional number system. So it is also having some set of input symbols. Each and every symbols in the calculation will be represented by its position. Okay. So next, the next point is, it is having hexa. Hexa means 16. Okay. So in total it is having 16 symbols or digits. Okay. The 16 symbols starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 9. Then we know that 16 means starting from 0 means 0 to 15. No? So here 10, 11, 12, 13, 14, 15 will be represented using 2-digit. But in case of systems, those 2-digit numbers will be replaced with the uppercase alphabets. Okay, that is, for instead of 10 we'll be using A, for instead of 11 we'll be using B, instead of 12 we'll be using C, that too in the uppercase letter, remember, and instead of 13 we will be using D, 14 E and 15 F. So since it is having 16 symbols in total, the base value for the hexadecimal is 16. Okay, so here see, the symbols A, B, C, D, E represent the decimal values 10, 11, 12, 13, 14 and 15. Okay. The maximum value of the hexadecimal input is 15. Okay. So and see here, the each position of a digit will be represented using 16 to the power of its position. Okay. So see here, is the example. The example is given as 1 A F. Okay, with the base point of 16. That is, the radix point is 16. Okay. So now we are going to calculate this hexadecimal value into our day-to-day life number. That is the decimal number. Okay. So how to calculate? For each and every number we have to give a position, that is 1AF. The positioning will be starting from the right hand side to the left hand side, that is, for F the position is 0, for A the position is 1 and 2. Okay, so see here, 1 into the power base 16 to the power 2 plus A into 16 to the power 1 plus F into 16 to the power 0. Okay. Then after calculating this, we will be getting this value 431 with the base 10, because now we have converted this number into the decimal numbers. Okay. So see here, this is the table for representing the numbers with each all the 4 different types of number systems, that is decimal, binary, octal and hexadecimal. See here, in decimal if you are putting 0 means, in binary it will be represented as 0000, because the pattern for representing binary numbers is 8, 4, 2, 1. Okay. And the octal numbers, as I said before, the octal numbers pattern will consist of 3 bits, because 2 to the power 3 is 8 and 2 to the power 4 is 16. So hexadecimal numbers will be represented using 4 bits. Okay. And the 1 will be represented using 0001 in binary, because 8, 4, 2, 1. So this one, only this bit will be enabled, and in octal the 3 bits will be represented, and hexadecimal 4 bits. And 2, here we know that the pattern is 8, 4, 2, 1. Okay, so the second bit will be enabled. In case of 3 means, both of these 2 bits will be, because 2, 1 is 3, no? So these 2 bits will be enabled. Okay. See here. For 2, this is the binary representation and this is the octal representation. Up to 9 it will be like this, and for 10, no, this is the binary representation, that is 8 4 2 1. 8 plus 2 is 10, so 1010 is the binary representation for 10, and for octal it is 12. Why? Because in octal representation this number will be this 2-digit number is there, no, this one number will be considered for one set of number, and this is represented using another set of numbers. So in hexadecimal 10 will be represented by capital A, okay, up to 15. This is the representation for the numbers from 0 to 15 in all the 4 different types of number systems. Then next is the converting a number system from one base to another base. Okay, now we're going to see, we are having one base is nothing but the radix point. The base is the main element which determines under which type the number comes. Okay. If the base is 10, it will comes under decimal. It is a decimal number system. If the base is 2, it is a binary number system. And if the base is 8, it is a octal number system. And if the base is 16, it is a hexadecimal number system. So now we are going to see about the conversion of a number of one base to another base. Okay, the first one is how to convert a number of another base. It can be 2, 8 or 16 to the decimal. How to convert, okay. So these are all the steps to be done for this conversion. First, we have to determine the position value of each digit. As I said in the previous examples, the positional value starts from the right hand side of the number to the left hand side. The position will start from the 0, 1, 2, 3 up to the length of the pattern number. Okay. Next step is the multiply each and every number, each and every digit with the corresponding base value. Okay, and then calculate the sum of the product. We have to multiply and we have to sum the values. See here, this is the example 4706 to the base 8. The base 8 means the given input is octal number system. Now we are going to convert this octal number into decimal number with the base of 10. What will be the answer? So see here, 4 into 8. Before that we need to set the position for each number. The position starts from the right hand side, that is for 6 the position value is 0. Okay, and for 0 the position value is 1, and for 7 the position is 2, and for the 4 the position is 3. So now we are going to multiply each and every number, each and every digit with its base point along with its power, okay, along with its position as a power. Okay, so see here, 4 into 8 to the power 3 plus 7 into 8 to the power 2 plus 0 into 8 to the power 1 plus 6 into 8 to the power 0. Then after processing we have to take the values. Then we have to what we have to do is sum of the products. This is the product values. Then we have to take a sum. This is the value, that is 250 is the equivalent decimal number for this octal number. So now we have converted the given octal number into decimal number. So the base is 10. Okay. So now see here, now we're going to see about how to convert a decimal number into any of the base. Okay, it can be a binary or octal or hexadecimal. The number with the base of 10 into any other base. Okay, the first step here, the method we're going to use for this conversion is division remainder method. That is, we have to divide the given input value and we have to all together we have to take the remainder values. Okay, like LCM method, like this. And the first step is divide the decimal number. The given decimal number should be divided, and then we have to record the remainder values. Okay, then divide the quotient value of the next one in order to proceed further. Okay. Then see here, record the remainder for step 3. Okay, and that means we have to repeat the division for each and every quotient until we getting the single value remainder. See here, this is the example 952 with the base of 10. So this is the decimal input. That decimal input should be converted into and the given base is 8. So now we have to convert this value into the octal number. Okay, so see here, so what representation that we have to convert, no, through that number we have to divide it. Okay, 952 is, if we divide it with 8 means that the quotient value will be 119 and the remainder will be 0. Okay, then after that this will be the remainder. So now we have to record the remainder. Then at last, in order to represent the given number after dividing until we reaching the single value as a input, what we have to do, we have to record all the remainders and then we have to write the remainders that as a converted value. See here, we have to, that too we have to write from the bottom to top arrangement. Okay, that is 1670 to the base power 8. In case if you are having 5 as the last remainder means we have to include this first, 51670 likewise. Okay, for example I am saying, so this is how we have to convert the decimal number in any other base. If we are going to convert it with binary number means then we have to start dividing this number with 2. If we are going to convert it into the hexadecimal means then we have to start dividing this number with 16. So the remainder value should be recorded together and it will be represented all together from the bottom to top. And next is the converting a number of any base. It can be of any kind of number system into another base. Okay, see here. Any kind of base. If we are 545, this is the example, and now we're going to convert it with 4. Okay, these base values will not determine any kind of the number system because the decimal number system has the base value of 10 and binary the base value is 2. For the octal the base value is 8 and the hexadecimal the base value is 16. But here we are having different bases, 6, 4. Okay, now we're going to convert these value into some other base. So see here, first what we have to do, the given input will be converted as decimal numbers, then from that decimal number we have to convert the value as with the base of 4. Okay, so we know that the base value is 6 and the position for this is 0, 1, 2. Likewise we have to multiply and all the product should be summed together. Then next is after that using division remainder method, because we know that while converting the decimal value we will be using the division remainder method. So using division remainder method we have to convert the value to any kind of base. If you are going to convert the value given output value into base 4 means we have to start dividing this value, this decimal value, by 4. Okay, then we have to record the remainders all together, then the output will be 3101. From the bottom to top we have to represent the remainder value with the base of 4. Okay, so now we have converted the 545 with the base of 6 into value with the base of 4, that is 3101. So next is converting a binary number to octal number. So the number with the base 2 should be converted with the base 8. Okay, let us see. So here is the example, the given numbers. So don't forget that binary numbers will be represented only using zeros and ones. Okay, and this is the given input with the base 2, that is the binary number. Now we have to convert it using convert it in order to get the octal number. Okay, let's see here. We know that octal numbers means it will be having 3 numbers in a group, altogether 3 numbers in a group. So see here, first step is divide the binary digits into the group of 3 starting from the right. Okay, starting from this right hand side we have to divide it the 3 numbers. Okay, so in this the first group is 0, 1, 0 and the next group is 101 and at last we will be having only single digit. So before that you just put the zeros in order to make it as a 3-bit. So 001. Okay, now these numbers are in the binary format that we know. See here, 001 into 2. So now we have to calculate it using the sum of products method. Okay, that is 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0, and you will be getting 1. and after calculating this 3 bit, this one, after calculating this 3 bit, this one. So 1 5 2 with the base of 8. This is how we are converting the binary number into octal number. Okay, so after converting, we have, don't forget to put the base point as 8. Then next one, converting octal number into binary. Okay, in last example we have seen about converting binary into octal. Now we are going to convert octal to binary. That means in order, we are going to convert the number with base of 8 into the base of 2. See here, we will be given with the example that 562 with the base of 8. Now we are going to convert it into the binary number. That means it will have the base of 2. The first step is we have to convert, we have to represent each and every symbol in the given octal number as the 3-bit representation. Okay, for 5, in the representation for 5 is 101, because in the 8421 pattern the octal numbers will hold only the 421. Okay, so for representing 5, 4 and 1 should be enabled. Okay, that is 101. For representing 6, 4 and 2 should be enabled, that is 110. And for representing 2, the 4 2 in the middle value will be enabled, so 010. Now each and every individual value in the octal number has been represented as has been represented as binary. So altogether it has been represented into the binary value, that is 101, 110 and 010 with the base of 2. This is how we are converting the octal number into the binary number. Okay. Then next is converting any binary number into hexadecimal number. How to convert the number with the base 2, that is the zeros and ones, into hexadecimal pattern. We know that hexadecimal numbers will have the 4 numbers in a group altogether, because 2 to the power 4 is 16. Hexadecimal will have the 16 symbols. Okay. See here, in the previous example, that is converting binary into octal, what we did, the given input will be starting from the right hand side, we have grouped, we have separated the input into 3 bits in a group. So in case of hexadecimal, we have to separate it 4 bits in a group. Okay, see here the given example. Now starting from the right hand side, we are dividing it into 4 bits, that is 1101. Then remaining we will be having only 1 1. So before that we have to put the 00 at the left hand side. Okay, so after splitting up we have to make the binary calculation. See here, 0 into 2, since it is a binary number, it will be having the base as 2. We have to arrange the position 0 1 2 3. So 0 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. So after calculating we will be getting 3. Then 1101. So 0 1 2 3. This 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, after calculating we will be getting 13. So we know that in hexadecimal representation, instead of representing the 2-bit values, we will be having the relevant alphabetical uppercase values. Okay, for 13 we will be using D. Okay, so the relevant equivalent hexadecimal value for this given input is 3D. Okay, after that we have to put the base as 16, since we have converted it into the hexadecimal number. Then next is converting a hexadecimal number into the binary number. Okay, so it just a reverse of the previous example, that is converting the number with a base of 16 into the base of 2. See here, the given example is 2AB. Okay, so for each and every number we have to represent it using 8421 pattern, that is also 4 bits, since we are going to we are having the input as hexadecimal. So see here, for 2 the decimal value is 8421 pattern 0010, and for A means 10. No, so for, instead of the replacement for A is the equivalent value is 10 and 1010. So the equivalent value for the B is 1011. So These are all the representations, binary representations for the each and every symbols given in the input. So then what we have to do, all together we need to represent all the 4 bits, okay, 0 0 1 0 for instead of 2, and instead of A 1 0 1 0, and instead of B 1 0 1 1. So now we have converted this hexadecimal into the binary number. Then at last we have to represent it using the base of 2, okay. And before ending up, let me revise what are all the topics we have undergone today. So before at starting of the session, we have seen about number system. So number system is the numerical value representation. How to represent the numerical value? It is a kind of method, okay. And the major classifications of the number system, then the what are all the characteristics of number system, then in that major classification, positional number system will be having 4 different types, that is decimal number system. The our day-to-day life, the numbers that we are using, we humans using, is the decimal number system, that it has in total it is having 10 symbols, that is 0 to 9. Then next is the binary number system. The symbols which is present in the binary number systems are 2, so its radix point is also 2. And next is the octal number system. Then the symbols which is present in the octal number systems are 0 to 7, in total 8. So the base point for the octal number system is 8. And next is the last number system, that is hexadecimal number system. So here the symbols of hexadecimal number systems are 0 to 9 and A to F, that is in total 16 numbers, 16 symbols. So the base point for the hexadecimal number system is 16. Then we have seen about the conversions among decimal to binary, binary to decimal, and octal to binary, and binary to octal, hexadecimal to binary, and binary to hexadecimal. Why we are using only the binary representation mostly means the processor which is present inside your system, any kind of devices will can process only the binary values, okay. That is zeros and ones. It is capable of processing only the binary values. Zeros and ones are the machine understandable values, okay. Okay, thanks for watching the